Hi, my name is Akansha Dixit and I am going to represent a very important topic of the chemistry which is called chemical bonding. So chemical bonding, let's take a small introduction of the chemical bonding. Let's relate to our human life. Every human wants to become stable. So they have to make different kind of relationship with different kind of persons. So when they make different kind of relationship, they make different kind of bonds between them. Some kinds of bonds are like friendship bonds, some kinds of bonds are like their marriage bonds. They are different kinds of bonds present in our human life because we also wants to become stable. Just like in chemistry, all the atoms and all the molecules also wants to become stable. So to maintain their stability, they also wants to become stable, and to maintain their stability also make the bonds between them so that they can exist in their form. Because atom is neutral, atom is neutral and it can be exist in their universe. But if atom has to combine to different atom, ions has to combine different ions, they has to make some bond between them, and they has to make a force of attraction between them. So this kind of force of attraction which makes them stable is known as chemical bonding. Now let's start the chapter by its basics. So we have a chemical bonding. So chemical bonding can be defined by its attraction force. So there are few things that we need to learn, that there is a attractive force is more than the repulsive force. When the attractive force between the particles, between the atoms are more than their repulsive force, so the chemical bond can be formed. Let me talk about attractive force and repulsive force. What is meant by attractive force and what is meant by repulsive force? Attractive force can be formed by different kinds, unlike charges, like it can be formed by electron and proton, proton and electron. It can be formed between two different kinds of charges, but the repulsive force can be present between electrons and protons and protons. So when the attraction force is more than the repulsive force between different kind of atoms, they can make their stability to form different kind of molecule and compounds and make them stable. So now we are going to discuss that how can they form their bonds. So chemical bond can be formed by three of steps. Either they can gain electron, they can lose electron, or they can share electron. So there are three types of thing by which they can make the bond between their atoms and different molecules. Electron can gain electron, elements can gain electron, elements can lose electron, and it can also share the electron to make them stable. Now we need to discuss that which kind of element share, which kind of element loss, and which kind of element gain their electron. I think we have discussed over that what are metals and non-metals. We have all the things between the non-metals and metals. So we have discussed this thing before, that metals are those substances which has a very large atomic radius. Metals have a very large atomic radius, so their ionization potential is very low. But non-metals have a very small atomic radius. Non-metals have a very small atomic radius, so that their effective nuclear charge is very high, so that they have very high electron affinity. So if we know these facts, that Metals have a very large atomic radius, so they can easily donate their electron to maintain their stability. And non-metals, they have a very small atomic radius, so they have a very large effective nuclear charge, so they have a very high electron affinity. So now we are going to discuss this, how the metal loses electron and how the non-metal gain electron, and what is the need to maintain their stability. So let's discuss about a rule. The name of the rule is octet rule, which is given by the Niels Bohr and Charles Berry. According to the octet rule, every element, every atom has to maintain 8 electrons in their last orbit, in their outermost orbit. So every atom has to maintain their 8 electrons in their outermost orbit to make their stability. Right now, if we have a configuration of sodium, the atomic number of sodium is 11 and the configuration will be 2, 8, 1. So it has a 1 electron in its outermost orbit. So it has two options. Either it can make 2, 8, 8, or second option it has 2, 8. So it has two options to complete their octet. Now we need to see that which one is more preferable to the Na. As we already know that Na is a metal and their ionization potential is very low. When the ionization potential is very low, so it cannot attract the 7 electron to its site. Whether it can donate 1 electron to make their atoms, to make their electrons. So sodium has 11 electrons, so it will give its 1 electron, it will donate its 1 electron to possess positive charge. So now sodium can make its proton, sodium can make its cation. So now the configuration of sodium was 2, 8, 1, but by donating 1 electron, it has 2, 8. Now the octet is complete and it forms sodium ion. And now it is stable in its sodium ion. So we discussed about the metal, a sodium metal. Now we are going to discuss about a non-metal. If I have an example of chlorine, the atomic number of chlorine is 17. If the electronic configuration of chlorine is 2, 8, 7, so it has also two options. Either it can form 2, 8, 8 by gaining 1 electron, or it can form 2, 8 by losing its 7 electron. As we know that chlorine is a non-metal and it has a very high electron gain enthalpy. It has a very high electron affinity. So there is a possibility to gain the electron. So the chlorine has a very high affinity. So it will gain 1 electron to form its anion. So there was a configuration 2, 8, 7. Now the configuration will be 2, 8, 8. So now we have discussed that chloride ion, it will form its chloride ion. So this is the process by which atoms can make them stable by losing their electron or by gaining their electron. So now what is the conclusion of this? The conclusion is that the metal has a very less ionization potential. So they cannot gain the electrons due to their very large atomic radius. So it has a very one option that it can lose their electron to make their octet complete. When they complete their octet, they will be stable. Just like non-metals, non-metals have a very small radius and very high electron affinity. Due to very high electron affinity, it has a capacity to gain their electron. So they can easily gain the electron to make their octet complete. When their octet complete, they can be form their ions. Now why we form these ions, what is the process to make the chemical bonding, as we have already discussed. Now I'm gonna discuss about how many chemical bondings are present and why they need to form their bonds. So I'm gonna discuss about the chemical bonding. There are three types. There are several types of chemical bonding. The first one is ionic bond. Ionic bond is also known as electrovalent bond because they gain and lost their electron to form their bond. Electrovalent bond. Another one we have covalent bond. Covalent bond is also known as molecular bond. They are also known as molecular. Third one we have coordinate bond. And fourth one is the hydrogen bonding. So we have four types of bonding here. Now we are going to discuss the first type of bond, which is known as ionic bond. Ionic bond, as the name saying, ionic, that means they have ions that we have already made. We made the sodium ion, Na1 positive, and we made the chloride ion Cl1 negative. Now we have to show how they form bond. We have already shown that how metal and non-metal make their ion to make them stable. Now we have to show that how they combine together to form an ionic bond. So the last orbit contains one electron. So we show the one dot in their electron dot structure. Electron dot structure is the representation of the electrons present in their outermost orbit with the atoms. Sodium atom has one outermost orbit electron and chloride has 7 electrons, 1, 2, 3, 4, 5, 6 and 7. Now what's gonna happen? Now sodium has a 1 electron that can easily donate to make them stable. So Na donate its electron to give chloride ion. And chloride, which has a very high affinity, which can easily take the electron, which can easily gain the electron by sodium to make it stable. So now sodium gives their electron, donate their electron, and chloride make it stable to gain the electron from the sodium. And they will form NaCl because there is just one electron is donating and gaining. And they possess charges, the same charges, Na positive and Cl negative. So now we have formed the ionic bond between the NaCl. Just like the NaCl, we can form the different kind of bonds. Let's take another example of magnesium and chlorine. Magnesium has an atomic number of 12 and chlorine has an atomic number of 17. So we can also form the magnesium 2, 8, 2. So it has 2 electrons so that he can donate its 2 electrons to form their magnesium ions. So it has 2 electrons with Mg2 positive and chloride ion 2, 8, 1 and it can easily form chloride ion. Now it can form the ionic bond just like Mg and Cl. Mg contains 2 electrons in its outermost orbit and Cl contains 7. Now Mg has to give 2 electrons, so it has to take another 1 chlorine to make them stable. So it will donate 1 electron to first chloride and it will donate to second electron to the second chloride to form their ionic bond. So now Mg possess 2 positive charge and two chlorine possess one negative charge. And the formula will be MgCl2. And the name will be magnesium chloride. So we have discussed the ionic bonding. So in the next session, we are going to discuss about how to elements share their electrons and coordinate bond and covalent bond forming. Thank you so much.